It's full of kids. You lay one of those on this, you're going to crush the 55-gallon drum.
We'll accelerate the process by pouring ice water over the drum.
Watch out, guys. This might be... There you go. Whoa, man. Awesome.
At 2,000 frames per second, we see the same reaction we saw earlier with the soda can. The cold water turns the steam inside into liquid and creates a vacuum in seconds.
Oh, whoa! Water didn't know what was happening, so we got those old cartoons, you know, we go over the cliff.
Alright, so if I go back for a second, it says, is air pressure strong enough to crush things like the tanker? The answer to that question would be yes. And if you notice when we saw that video there, you notice that all the air pressure inside of that steel drum actually became crushed when they put in that cold liquid water and ice together over it. It made that air inside become a liquid, and it crushed that steel drum without any problem. Let's take a look at this pressure behind a dam here. So if you take a look at these pictures here, you see that the water, even though it's nice and still and it appears to be calm, there is pressure being put on there. All the water is actually putting pressure on the dam there. The dam is holding it up. That water, even though it's really calm, you can see how powerful and how much pressure it can put on. So, let's go ahead and take a look at this video of this dam and its flooding gates. Alright, if you took a look at that video very carefully, remember earlier we saw the video of the water that appeared to be very calm. And of course it was putting all this pressure on the dam. Well, you saw that once the gates were opened, that water was applying so much pressure, it was coming out, it was extremely powerful as it was coming out through the gates. So you had an idea of how much pressure was actually being applied onto the dam. So let's take a look at this video of this dam demolition. You're going to see this dam is about to be exploded. It was holding up water, but they no longer need it to hold water. Take a look at this video.
Thousands of people have been 600 meters long and 150 meters high, vanished beneath the waters of the great Yangtze River in a matter of minutes. This temporary dam was built a few years ago to hold back the waters of China's longest river to allow construction of the controversial Three Gorges Dam, the largest in the world, which lies just 100 meters or so further along the river.
Alright, boys and girls, so if you notice that video there with that dam was holding up the water and they no longer need it. But you saw after that explosion, the pressure that the water was putting on the dam actually was extremely powerful. And you notice as soon as it exploded, the water basically just swallowed up that entire dam as it fell through the water as it exploded. Lots of pressure. Alright, boys and girls, let's go ahead and talk about air in the atmosphere, air that's around us. So we would say, if there's only a little amount of air, then there's only a little bit of pressure. But if we were to take a look at, in this case, we have a slide here of a football stadium. So let's compare it to that of a cricket stadium. If we were to look at the air here, it would be full of air. Therefore, there would be full of pressure as well. And let's take a look at this slide here. As we look at this slide here, what we want to get an idea is, the lower you are to the ground, the more pressure that's being put on you. So if you take a look at this slide here, we have, it appears we have 1 square meter of air is equivalent to the amount of gravitational force of 1 atmospheric pressure at our surface level. So if you were on the ground, let's make this a little easier. Just as you are now, you're standing on the ground in front of you. And as you're standing on the ground in front of you, it would be as if all this pressure that is being put on you now that you do not realize is kind of equivalent to, let's say, if I were standing on you now, we'll get me and maybe 5 of my friends go ahead and stand on you now, would be all the pressure that is being applied on you now. Alright, so let's go ahead and let's come back to this this air we were talking about earlier. So, air in the atmosphere that's pushing on us from all sides with this incredible force is about the size of a rupee, which is being pushed on by 1 kilogram of pressure. So there's actually 70 kilograms of pressure that's being pushed on just your head alone. That would be like me standing on top of your head. So, if I were to do that, your face would probably look like this now. Alright, let's take a look at this teddy bear. If we look at this teddy bear, there's actually pressure, air pressure, that's being pushed on the outside of the balloon, just as there's air pressure being pushed on the inside as well. What happens is, both air pressures balance each other out. Therefore, the inside walls of this balloon here is having air pressure that's being pushed on the outside of the walls of the balloon, just as it's being pushed on the inside. Alright, boys and girls, so let's take a look at this bus here. Alright, imagine all the people that are packed onto this bus. Do the people that are on the bus, on the inside walls of the bus, or on the person in the middle bus, do they feel all this pressure? So if you were in the middle, would you feel pressure right now? Let's think about that. Would you feel pressure? Well, let's try to answer this next question here. Why don't we feel the air pressure? Why doesn't it crush us? So we know there's all this air pressure around us. Why doesn't it crush us? Well, there's air inside of us as well. So what happens is, just as there's air pressure being forced on us, we also have air pressure that's in us that's balancing us out here. Therefore, we do not feel it, and we're going to move on. So the air pressure balance, as we were discussing, we have a table here, we have a tree here, we have a building as well, and as we discussed, all of these things, just as we talked about earlier when we were talking about our desk, and we applied pressure onto the desk, well, just as we're applying pressure on the desk is actually applying pressure right back at us. And over here, on this desk, just like there's air around us that's applying pressure on the desk, there's also air below the desk that's also applying pressure right back on the desk. So we'll get into that a little later next time. Hopefully a little better. So another question that was submitted by you is air pressure always this strong? Well, we have a couple of slides here. We discussed this water over here that was nice and calm, that was applying pressure onto this dam. And then we have a picture of the rain over here that seems to be coming down. Well, is it always going to be this strong? Well, we're going to get into that next time.